Throughout this video, you're going to see different suppression methods that are available at metal manufacturing and recycling facilities. We're going to show that with the available sand and Class D extinguisher, suppression and extinguishment can take place. However, due to the delay of 911 activation and the arrival of department personnel, these fires will soon grow too large for the methods shown in this video. The metals used in the following demonstration are titanium, magnesium, and aluminum. We're going to show how effective the application of sand, the use of a Class D fire extinguisher, water, and a fire suppressant gel are used in extinguishing metal fires. First up is sand. As you can see, sand worked very well. If the fire is attacked in the incipient or initial stages, this method is very effective. Keep in mind, however, that the application of large amounts of sand for a larger fire would be difficult. Another consideration when using sand is the containers tend to build up moisture within a few inches of the dried surface. If wet or moist sand is applied to a metal fire, it can produce a violent reaction similar to water. Next up is the Class D extinguisher. Class D extinguishers can be identified by their yellow color, come in various sizes, and are usually stored throughout the metal facility. This method is effective. However, you will notice that the reach of the product from the nozzle is very short, and it takes quite a bit of product to extinguish a small fire. This method would also be ineffective for larger fires. Next up is water. As you can see, applying water creates a violent reaction. Combustible metal fires burn at extreme temperatures, 5,000 to 8,500 degrees Fahrenheit. When water, H2O, is applied at these temperatures, water will dissociate and revert back to its base elements of hydrogen and oxygen. In other words, hydrogen becomes a free-burning fuel and oxygen acts as an oxidizer that accelerates the burning rate. For every 100 gallons of fire flow on a combustible metal fire, there is a potential release of hydrogen equivalent in energy to that of 43 gallons of gasoline. Last up is a fire suppression gel. It's a powder additive that, when properly mixed with water and agitated, will create a gel that breaks the fire triangle by suffocating the oxygen from the fuel and rapidly cooling the heat source by adhering directly to the burning material. When used correctly, it's an effective extinguishing agent for metal fires. It cools the metal faster, and it keeps it below its ignition temperature without having a violent reaction, even though it's a water-based product. Training is currently testing this product, and future testing will include dry powder reductors for larger fires. Most often, combustible metal fires will be too large to extinguish or suppress with the method shown here. Letting the fire burn may be the best tactic. When encountering these fires, keep in mind SIE. S, separate, I, isolate, and E, exposures or extinguishment. Remember, separate the fire from the spreading to other combustibles or like products. Isolate the fire to its area of origin and protect product, areas, and structures exposed to the fire, and extinguish if proper agents are available, or let it burn out. A combustible metal fire. Offensive mode will consist of 1. Evacuate civilians. 2. Full PPE within the IDLH. 3. Determine if you can separate and/or isolate. 4. If safety permits, extinguish with appropriate extinguishing agent. A combustible metal fire defensive mode will consist of 1. Evacuate civilians. 2. Full PPE within the IDLH. 3. Determine if you can separate and/or isolate. 4. Maintain safe distance. 5. Protect exposures. Runoff should not contact burning material. 6. Allow fire to burn itself out.